Welcome to the Smart Building Center, an energy efficiency innovation space for the commercial, industrial, and institutional building operations industry. Our focus is where smart meets safety, comfort, and efficiency. And we offer state-of-the-art training and meeting spaces, educational programming, and a tool lending library with a wide spectrum of monitoring and diagnostic tools available to borrow for free. We also offer educational resources such as this training video. So in this video, we'll use data loggers to verify that economizer controls are working properly. So what is an economizer? Well, an economizer is a control strategy that essentially means free cooling by using outside air. This minimizes the costly mechanical cooling when conditions permit. And it's a great energy saving strategy. Unfortunately, economizers are often not working properly, and the Pacific Northwest National Labs, in fact, estimates that about 60 to 70% of economizers are not functioning properly. So this is a big opportunity for savings that is often missed. And economizer control happens a couple of different ways. Often in packaged rooftop units and air handlers, the control happens via the integrated controllers for the unit, and so remote monitoring is not an option. And this is where data loggers can be really handy in verifying that the control strategy is working properly. In more sophisticated systems, you have the control being done by a building automation system using direct digital controls. And these can be remotely monitored, and trend logs can be set up to view the data over time and verify or identify that the strategies are working as intended. But data loggers can be really useful in this situation as well, as kind of a double check to make sure that sensors are calibrated correctly and there aren't other anomalies that you might miss on the building automation system. So in this video, we'll look at an air handler unit, this packaged air handler unit here, that is controlled by a building automation system. But the concept is the same for standalone systems. And we have basically two different economizer sequences. One uses a dry bulb sensor, and the other uses a wet bulb temperature sensor or enthalpy method. In this video, we'll look at this system, which uses a dry bulb sensor. And these are a little simpler, a little more reliable. These should be checked for proper calibration at least once a year. The enthalpy type of control is a little more prone to failure and should be rechecked at least twice a year. Manufacturers sometimes will ship these units with one or the other type with no regard for where it's going to be installed and what climate. So it's good to know what type of control you have, what type of sensor you have, because this could also be an opportunity to retrofit that sensor depending on your climate and application and the control strategy. You might see additional savings. Okay, so I'm going to go ahead and place our data loggers, and I want to make a note about safety. It's really important to de-energize any fans using a lockout tagout system, any electrical equipment at all, before you place sensors or work near any kind of equipment that could be hazardous. So I've got the fan de-energized here. Everything's shut down, and it should be safe to open the access panel. So we have our panel open here. You can see the outside air damper wide open currently. You can see the actuator for the damper and the linkage. So when troubleshooting an issue that may come up, you always want to check and make sure the actual mechanical system is working properly. The linkage and the actuator are physically opening the damper. So you can see here I've secured the sensor in a position to where it's not going to touch any other surfaces and will stay secure for the duration of the logging period. So I've got this handy test port already installed in the door. So I'm going to just remove the test port cover, feed that sensor cable through, and replace the access door. And now, as you can see, I've placed another sensor in a similar way, secured in a place where it's not going to touch another surface. And this is in the mixed air chamber just past the filters. So here I've placed another sensor just in front of an outlet for the return air duct. And up here I have the supply air sensor running through a test port directly into the supply duct. So I've got my Hobo UX120 4-channel data logger here, and I've programmed it to work specifically with these temperature sensors, and it has a handy set of magnets on the back, so I can go ahead and just stick it to metallic surface, and then I'll go ahead and plug the data logger leads into it. These are all programmed to start logging at exactly the same time. That makes it a lot easier when we import the data. And we'll go ahead and leave these for at least a couple weeks so that we can have a logging period that shows occupied and unoccupied times, various temperatures, and in case there are any anomalies, we have a long enough data logging period that we can account for those. So here I am with Pat, the controls lead for this building, and he's got the building automation system interface pulled up with this specific air handler. So Pat, tell us what we're looking at here.
Okay, what we're looking at is the trend for the air handler on the building automation system. So you'll see that the pink line is our outside air damper command. The green line is our outside air temperature. The red line is our return air temperature, the orange line is our mixed air temperature, and the blue line is our discharge air temperature. You'll see that when the air handler starts, the mixed air temperature is going to be tracking our outside air temperature. At a certain temperature outside, around 72 degrees, you'll see that the outside air damper goes to its minimum position at 25%. And our mixed air temperature starts tracking now with our return air temperature. Because we're in cooling season, the outside air damper is going to either go from 100% to its minimum position, depending upon the outside air temperature.
Great, thanks Pat. So it looks like the economizer is working as we would expect it to, at least in cooling mode. So now we'll go ahead and download the data from the logger and the sensors that we placed and see how that compares. So I have my data from the data loggers pulled in here to our HoboWare Pro software, and I've got the specific day we were just looking at in the BAS trend logs pulled up here. So you can see as the system starts to ramp up for the day, the green line represents the outside air temperature. You can see that we're starting to let in as the outside air damper opens. We're letting in that cool outside air, and the orange dashed line shows the mixed air temperature, which is tracking very closely with the outside air temperature all the way until we get to about 2 o'clock, where we see that the outside air temperature continues to rise, but the mixed air temperature starts tracking very closely with the return air, which is this red dashed line. So that's indicating that we're no longer economizing, and this is very consistent with what we saw on the BAS trend log. So we can assume that our sensors are calibrated properly. Next, let's look at some examples of economizer trends in different scenarios, both functioning and improperly functioning. First of all, let's orient ourselves back toward our air handler. This is a diagram from the BAS system of the air handler. So, of course, you can see here your return is in red, and that is feeding into the mixed air, which is in orange, and we also have the outside air coming in here to the mixed air chamber. We then have our heating coil, our cooling coil, and flowing on through to the supply duct. And here we have a trend log showing an incorrect economizer function. So you can see here that around 11 a.m. our outside air damper is going to its minimum position, even though our outside air temperature is still well within the range that we could be economizing. It's remaining in the 60s and would be an opportunity for free cooling. You can see that the orange mixed air temperature line starts to track more with the return air temperature line. So we're really missing out here on a lot of opportunity to reap the benefits of that free cooling. In this case, the damper is modulating properly, so we probably don't have necessarily a stuck damper or linkage issue. It's probably more going to be a programming error. So that should be looked at and corrected to reprogram that to minimize the mechanical cooling. And here we have an example showing how much energy could be saved, can be saved in an economizing strategy. So here we have the economizer operating properly up until about 11:15 a.m. And that is where we see the mixed air temperature rising quite a bit and tracking with the return air temperature instead of with the outside air temperature. You can see here how when we were in economizer mode, we had the cooling coil command, that's this light blue line, is only around 10%, is all the mechanical cooling required to keep the desired temperature. And it looks like once we stop economizing, we have we're using about 30% of that cooling coil energy. So this can translate to quite a bit of energy wasted. Potential issues that could cause economizers to not be working properly would be programming issues, sensor calibration, the damper actuator motor has failed, either failed with the damper open or closed, or the linkage is broken. Thanks for joining us. To browse our tool inventory and check out our other offerings, visit our website at www.smartbuildingscenter.org.